So, inverses. Talked about this before. So, an inverse relation or an inverse will undo a given relation. And I'm not using the word function here. If you like think way back deep down in your knowledge, a function, the x values do not repeat for it to be considered a function. Everything is under the relation umbrella. So any type of graph, table, etc. is considered a relation. To be considered a function, it's more specific. The x values can't repeat. So every inverse relation can be found by switching each x and y values. So inverses, the x's and y's are switched. So if I have one function and I look at its table and I find its inverse, the x's and y's are flip-flopped. So in some situations, finding the inverse, super straightforward, super obvious. Table, obvious. When you get to like graphs, a little bit harder. Equations, there's a little bit more that we have to do. But it is important that we understand the concept of inverse relations because you're going to see them a lot. You kind of have to understand what's going on. So in tables, if this is my original relation and I want to find the inverse of it, the inverse, the x's and y's are just switched. So if we called this f of x, we would call this f inverse of x. Oh yeah, sure. So that's f of x, f inverse of x. And all I did was I put the -1 and 1, switched them. The 2 and the 3 switched them. Is the original table a function? Yes. So the original table is a function because each x has exactly one y. I don't have the same x value going to two different y's. Is the inverse a function? No. The inverse is not a function because you could explain this a few different ways. I'll just say because the x values repeat. The 2. You have a 2 that has a 3 and a 2 that has a 6. So when you're given a table and you're asked to find the inverse, you could go to the side and make a new table. That is one kind of strategy. So you could go through and switch 6, -2, 1, -1, 2, 0, -3, 1, 0, 2, 5, 3. So number 1 says find f inverse of 0. So I would go to my inverse table. If it's in parentheses, it's your x. So I would find when the x is 0, that equals 2. You could also just know when you're doing an inverse, if the number's in parentheses on inverse, it's backwards, you could look up here for where the y is 0 and then go back and tell the 2. I mean, it's just, this is really just thinking it out, but writing out kind of your steps. Or you can just do it in your head. But if it's the inverse, f inverse, you're looking at f of x, but you're looking at it backwards. So f inverse of 2 is what? 0. F inverse of 1 is -3. What is f of 1? Oh, wait. Negative. No, that's right. -1. What is f of 1? -3. Right. If you're looking at a graph and you're needing to find the inverse, you kind of just have to draw it out, is the best way to do it. The easiest types are the ones that like everything is just a straight line. Straight line. So what I would do is I would make a table. So we might do that over here. X and Y. And I would just jot these 4 points, kind of like those corner, those important points. -2, -1. -1, 2. 2, 1. 4, 3. So that's the original. And then my inverse, if I found the inverse of that, I could switch the x's and y's. So inverses, your x's and y's are just switched. And then I could graph these points and connect the lines. So -1, -2, 2, -1, and then those would be connected. 1, 2, those would be connected. 3, 4. So if you have a graph, that's kind of the process I would take to find the inverse, like write out your tables. Now this isn't really that obvious, honestly, but inverses are actually reflected across the line y equals x. So when I drew that line in there, if you can imagine me folding my paper along that line, they would overlap, right? Can you kind of see that, visualize that a little bit? It's kind of like a mirror, this line. So y equals x is like you have 0 and then you just go up 1 over 1, up 1 over 1. So the graphs of inverses are reflected over the line y equals x. So that's just something that's true about inverses. And it's figuring those out, figuring out your points when you have these just straight lines. It's just as much as doing a table. When you have a graph that's not linear, for example, you got curves involved. Here's kind of the process for doing that. First, sketch the line y equals x on the graph. Okay, because we know that it's reflected across that line, we're going to reflect it ourselves. So the line y equals x, it starts at the origin and just goes up 1 over 1, up 1 over 1. It's this line. So that's the line y equals x. So if my original function is that parabola, the inverse is going to be reflected across that line. And here's how we do that, because it's not like when you reflect across an X or Y axis, it's a little easier than this. So any points that fall on that line are going to stay on that line, the inverse. So like our inverse is going to have those 2 points. So mark any points from the original graph that are already on the line. These points will stay the same. Okay. So then the next thing that you could do to help you get the inverse, find any points that are like nice points that fall in the corner. For example, this one is the point 2, 0. Okay. That point, and really I shouldn't have drawn that point in. I should have just noted it. The point 2, 0 is on my original function. What would this point be on the inverse? 0, 2. So you can tell that by just switching the X and Y values. Another way you can reflect it is if you count up 2 to my orange line, then I go over 2. So you count up and over the same. You kind of go up, over. Kind of how you reflect that. For example, the point 0, 4, to get to my orange line, I would have to count 1, 2, 3, 4. So then I go 1, 2, 3, 4 down. And it becomes there. And so you kind of just do as many points as you can, and then you'll connect and draw it. So for example, the point 3, 1 will become the point 1, 3. Or you could have gone up, up, left, left. That's what it looks like if it's reflected across this line. So those are inverses of each other. We'll do another one before you decide that it's too bad. You won't have to actually do this on the AP exam. You won't have to draw the function in its inverse, I don't think. They're very specific about the types of things that you will have to do, like on the free response. So then this other one, you really could probably actually just do this by making a table and picking out as many points as you can. So any point that falls on my orange line here, that point is going to be on the inverse. That's going to be part of my inverse. Okay. All right. So there's not as many points that fall on a nice point, like right in the whole numbers. So for example, this point right here, if I want to reflect it, basically I want to go the same distance. So from here to here, and then I would turn and go left about that same distance. And that's where it reflects to. So this point is really, it looks to be about 0.5, negative 0.5. And so if I reflect it, it's going to come to about right there. Okay. So at this point, that maximum right there looks to be, what I could do is I could go, okay, well I'm going, it's down here, 1, 2, 3. Oh, that one's about -1 too. So it would be 2, -1. It would come over here. The point -2, 0 would become 0, -2. That's an easy one I can put. Now the problem is we have all these points. We got to figure out how they're connected. Okay. Looks like it's going to be like that. Kind of yucky. Okay. Don't expect to have to do very many graphs. Or any graphs. So when you have functions, now this is what you might see this. You have a function, and we did these types of problems in Algebra 2. F of x equals 3x minus 7. That's the same thing as saying y equals 3x minus 7. F of x and y is the same thing. So what we did in Algebra 2 is we started by switching the x and the y. So I'm going to rewrite this equation, but with the x and the y reversed, because in inverse functions, your x's and y's are flipped. So I'm going to rewrite it as x equals 3y minus 7. And then I'm going to solve that for y. I'm going to solve that to get y by itself. So I would add 7 to both sides, which makes this x plus 7 equals 3y. And then I would divide both sides by 3 to get x 7 over 3 equals y, but I'm going to call that y inverse. So the inverse of 3y minus 7, if I made a table of several points and for 3y minus 7, and then I did a table of points for the x plus 7 over 3, your x's and y's should be flipped. Notation-wise, if we have f of x and we find the inverse of that, we write it as f inverse of x. It's not, the -1 doesn't go at the very end. It goes right after the f. Now, doing equations that have multiple x's is a little harder. There's some more algebraic steps that have to be done. So the steps are kind of written out here if you want to follow through with those. But I'm starting with y equals x minus 2 over x plus 3. The first thing we want to do is switch the x and y values. So I'm going to write this as x equals y minus 2 over y plus 3. Yep. So any y becomes an x, and any x becomes a y. And our goal is to solve it in a way to get just one y all by itself. And so you'll pretty much always do the same steps with these. Number one, I would cross multiply. It's kind of step 2. You might want to write cross multiply. So when I cross multiply, when I multiply each of those terms by x, it becomes x times y is what? xy. X times 3 is 3x equals, and then just y minus 2. So that's our step 2, cross multiply. Then in step 3, basically our goal is to get y by itself. So anything that has a y, we want to get it to the left. Anything that doesn't have a y, move it to the right. So basically this y's got to come over there, and that 3x has to go to the right. So it'll be x, y, minus y, because that one's going to come over there, so it's negative, you got to subtract it, equals, when that 3x moves over, it's going to be negative 3x minus 2. That's step 3. Step 4, we're going to factor out a y. So since both of those have a y in it, I'm going to factor it out. I'm going to put it in the front, which is going to leave me with x minus 1. And then we're going to divide both sides, and I'll show that step here. Divide both sides by x minus 1, and that gets your y by itself. X minus 1. X minus 1, not x minus y. But if you have to find the inverse and you have x's on top and bottom, you're going to do those steps. Cross multiply, get all the y's together, factor out the y, divide. A lot of steps, but if you do enough examples, hopefully you'll kind of remember those steps. Okay. So now we're actually going to get into some examples. I'm just going to do 2. So number 4, that's not multiple x's, so it's the easier one of the two. So this is the same thing as y equals. So my original function is y equals 2x squared plus 5. And I want to first switch the x and the y. So to find the inverse, I switch the x and y. What would my next step be? Subtract 5 from both sides. Good. So this would be x minus 5 equals 2y squared. Then what? Not yet. Divide by 2 first. X minus 5 over 2 equals y squared. And then what's my last step? Square root, yep. Square root. So the square root of x minus 5 over 2. It's y inverse. I will add the video that I did in my Algebra 2 class, and I do a lot more examples of just these more general basic ones. We didn't do any like this in Algebra 2, but we did do some like this. So I can add that if you get stuck on one that's like this, you can go back and look. Okay. Number 5, this one, I've got a fraction. Notice I have multiple x's, so it's going to be one of the longer problems. Okay. But this we know is y to start out with. And to find the inverse, you always want to start by switching your x and y. So x equals 2y minus 3 over 5y. What should I do first? Cross multiply. So x times 5y is what? What? 5xy, yep. 5xy equals, and then 2y minus 3. Then we want to get everything that has a y on the left, everything that does not have a y on the right. In this case, the only thing that I need to move is this 2y. So 5xy minus 2y equals negative 3. What's next? Can't combine because this has xy, this one just has y. So you can't combine those. What does step 4 say? Factor out a y. So y. So I'm going to take the y's and basically move them to the front. And I'm left with 5x minus 2. Yes. Equals negative 3. Then what? Step 5. What's the first word in step 5? Divide. You're going to divide by what you've got in parentheses to cancel it out. And so we have negative 3 over 5x minus 2. Tomorrow we'll practice these tomorrow. Now, the last piece of this, if I give you two functions and I ask you, are they inverses? You could just take the first one and find the inverse of it and see if it matches the other one. The problem with that is sometimes there's multiple ways to write a function. So sometimes it may not look like they're inverses, but they really are. Okay, and so another way to more formally check that is, here's the thing. If we're using composition of functions, f of g of x. If you plug, so if you have two functions and you want to know if they're inverses, If you plug G into F, that should equal X. And you simplify, do all the mathy algebra stuff, it should equal X. And in reverse, G of F of X equals X. So you kind of have to work both of those out and see if when it's simplified, see if it equals X. And if it does, we can say that they are inverses of each other. So for example, I have 2x minus 3 and I have 1/2 x plus 3/2. And I need to know if they're inverses. I've got to do both of these things right here. So f of g of x. I'm taking this function and putting it into f. So I'm taking this and putting it into there. And I'm going to see if that equals x. And so what I'm going to do first is distribute the 2. What's 2 times 1/2? 1. So this would be 1x, or just x. 2 times 3/2. 3. So plus 3. And then this minus 3. Those would cancel, leaving me with x. But I have to see if it's true in reverse to know for sure if they are inverses of each other. So I'm going to take f of x and plug it in there. So if I distribute, what's 1/2 times 2x? 1x. 1/2 times negative 3. Negative 3 over 2. Plus I have this 3 over 2. So those cancel, leaving me with just x. So are those two inverses of each other? They are. If both of these equal x, we can say that they are inverses. So we're going to do as many examples as we can get through. I don't know if we'll get through both of them. So basically, I need to take this in there, and then this one, put in that x. It doesn't matter which one you do first, really. Now, if the first one you do doesn't equal x, is there any reason to do the other one? No, there's not. If it doesn't equal x, then it doesn't matter what the other one equals. They're not going to be inverses. Okay. So I'm going to take this x squared plus 10 and put into that x. Okay, and that becomes the square root of x squared plus 10 minus 10. And minus 10 do what? cancel. So it's really the square root of x squared. What is the square root of x squared? X. Good. And then I'm going to take this whole thing and put it in for that x. And it's going to look like that. So you have the square root of x minus 10 to the second power plus 10. When you have a square root and a squared, they cancel each other out. And basically we're just left with x minus 10 plus 10, which is x, because the negative 10 and the positive 10 cancel. So are they inverses? Yes, they are. The next one has fractions. Yuck. Okay. I'm going to do it because I guarantee you'll see some fractions on the AP exam. This one x. For fraction. Right. You remember probably in elementary, maybe middle school, dividing fractions. What was that rule that you learned? Keep, change, flip. Remember that? Heard that? To divide fractions, you keep the first one, you change that to times, just leaves you with x minus 4. Now let's go in reverse. We're going to take this and put into that x. So it's the 6 over that mess goes there. And then you have, oops, I got those flipped, didn't I? That should be a plus 4 and that should be a minus 4. Because the 6 over x plus 4 goes there and then we still have the minus 4. What do we notice right away that we could do? The 4's, right? Positive 4 and negative 4. So this is really 6 over x. Which is the same as saying 6 divided by 6 over x. And I need to do what? Keep, change, flip. Keep the 6, change to times. That's really 6 over 1. Keep it, times x over 6. Cancel out a 6 on top and a 6 on bottom, leaving me with x. It's a lot of nasty work.